Welcome back to 12.9, and we are continuing to look at the Pythagorean theorem by looking at the converse of the Pythagorean theorem. And what this is saying that is, if a triangle has side lengths where this is true, then it must be a right triangle. So if you're trying to determine, hey, is this triangle right? You could see if that is true. That's what the converse is saying. So now let's take a look at this. Consider all triangles that have a side length of A units and another side length of B. And we're still just kind of keeping those lengths A and B, so and our hypotenuse is C. When the angle between the two sides is a right angle, the hypotenuse will be C because of the Pythagorean theorem. But when the angle between the two sides is less than a right angle, then the third side is going to be shorter than C, shorter than the hypotenuse. And when the angle between the two sides is larger, so here, remember this is like an acute triangle, here this is our obtuse triangle. Here, if it's larger than a right angle, then the third side is going to be longer than the hypotenuse. And you can kind of think about that as like little angle, little side, bigger angle, bigger side. So the converse is useful for making right angles. So if you construct a triangle and you've got three sides and they're 5, 12, and 13, then because this is true, 5 squared plus 12 squared equals 169, which is 13 squared, then there must be a right angle between 5 and 12 feet. Let's do some examples. So town B is 380 kilometers due south of town A. So town B is 380 kilometers due south of town A. And town C, if you're north, west, east, south. And town C is 460 kilometers east of town B. East of town B, 460 kilometers, town C. What is the distance from town A to town C? Now, we do know that this is a right triangle because when you make a directional change from south to east, that is 90 degrees. So because we know that, we can use the Pythagorean theorem. This is across from our right angle, so this is our hypotenuse. So we might want to call this A, B, and C. So A squared plus B squared equals C squared. So that's 380 squared plus 460 squared equals, we don't know, you can keep it C squared. So when we type that in, we're going to get that totals to this sum here, and we'll square root both sides, and we get approximately 597. So about, let's just say 600 kilometers. Let's do another example. What length ribbon will you need to stretch from the top of a 25-foot pole to a spot on the ground that is 10 feet from the bottom of the pole? Well, let's start by drawing the pole. So we know it's a 25-foot pole to a spot on the ground that is 10 feet from the bottom. So 10 feet from the bottom. What length ribbon will you need to stretch from the top to this spot? Now, in this problem here, we know that a pole is perpendicular to the ground, so we can use the Pythagorean theorem here again. This is going to be a right angle, which is going to make this the hypotenuse. And so we can call this A, B, and C. So A squared plus B squared equals C squared. And so we're going to say, okay, 25 squared plus 10 squared equals, we don't know. When we type all that in, we get 725 equals C squared, square root both sides. We get approximately 26.93. So we could say that it's about 27 feet, that ribbon. Let's do another example. So Carmina and Antone measured that the distance between the spots where they are standing is 10 feet 7 inches. So Carmina and Antone are 10 feet 7 inches apart. When measuring, Antone held his end of the tape measure 4 inches higher than Carmina's end, where I'm definitely going to have to draw this. If Carmina and Antone had measured the distance between them along the floor, would the distance be appreciably different than what they measured? Okay, so let's see here. This is what they did. Oop, looks like that's two separate pieces. Okay, this is what they did. We've got Carmina standing over here, and Antone standing over here. And they measured that the distance between them is 10 feet 7 inches. And we're talking about inches here, so let's just turn everything into inches. 10 feet is 10 times 12, so it's 120 inches plus 7 inches. So their distance is 127 inches. So what we're saying is that their distance could be 127 inches, but Antone actually held his end of the tape measure up 4 inches higher than wherever Carmina's end was. And so we have this potential distance here. They measured this distance. Antone held his end of the tape up 4 inches higher. So this is what they measured, 127 inches from here, not from the ground. And they want to know, hey, is that any different than if they would have measured it? Is that the same? Right? So let's take a look here. So if they measure, let's just do this. We don't know this measurement here. So that means this is C, this is A, this is B. So we don't know A squared, but we know 4 squared is equal to 127 squared. So it's A squared plus 16 is equal 16129. So subtract 16 from both sides. We get A squared equals 16113. A is about, when we square root it, 126.94. 126.9. That's really, really close to 127. Let's just make sure that if this started out being 127, let's just double check that distance. So this would be our hypotenuse still, so A and B. So this would be A squared, 127 squared, plus 4 squared is equal to C squared. When I type all that into my calculator, I get 16145. I'm going to square root both sides, and I get about 127.07. So how far off are they? I mean, truly not that far off. So would the distance be different than what they measured? They're really close. So I would say no. I would say this is a pretty decent measuring job. Go ahead and give these a try. I do encourage you, please try the challenge. I just put that there so you know that if it's a little more difficult, just draw your pictures. You can do it. And then press play when you're ready to see the solution. And that concludes this section.